put some music on for myself. Okay, I'm not hearing anything. I think I have to be here. Oh yeah. Yeah, okay. It compiles, I made these changes. Got rid of the base pipeline characteristic done. Add a virtual function that says if it is well derived from at shader stage. Added a filled state for the characteristic range task, and well, more changes in that neighborhood. Created an M needs signals bit mask in characteristic range. That should collect the number, the signals that it needs, and therefore the states. Number of running tasks is now replaced with the count of the number of characteristics that need a certain signal, and therefore have that state. And then I start them all anyway, I think. That would be wrong, wouldn't it? Yeah, that's definitely wrong. So I think I have to look at this file here. Okay. Yeah, so this is the first time I'm counting something. I'm counting the number of characteristics that say that I need a do-fill signal. And then I'm running over all characteristics and I give them this do-fill signal. What? Why? Yeah, what if I do not do that? Because if they're not waiting for that signal, then they're just ignoring the signal, do-fill, so might as well do it. I mean, it shouldn't cause a hang. But maybe, you know, let's say I'm testing that again and just not doing it for once I don't need it. Should test it again. If it needs to fill, let me do this, and otherwise we don't. I don't think it will fix anything. Well done. How's my neck? The same thing here. Only send it do preprocess signal if it is waiting for that. Now I've got the feeling that I might as well do this here. because I cannot send a signal before or after it waits for it. Although nah, it's not safe. Okay, there's one more here. Yeah. Do compile. Okay, now what do I expect? I have at the moment, as simple as possible, just one pipeline factory. A bit of the other way around. I have one pipeline factory that creates one pipeline. That's not true. Well, I have one pipeline factory that has two characteristics. One characteristic is the base pipeline characteristic, which is not a range, and that would require no signals whatsoever. And I'm kind of confused not to see that back here. Oh, okay, yeah, well, I know, it's not here. So the constructor of the base class sets need signals to 0. So we don't need any signals. Don't want any signals. And then when it is being created, because you know, here I call add characteristic with this type, and that function creates it here, new that characteristic, and it calls set signals on the just created characteristic. So what would that call? Well, that would call set need signals. Well, this class doesn't have it, so that must be from the base class. And characteristic doesn't have it, so that must be of the base class of that one. And that is, or does it not have it? No, I'm not sure. Set in the end, I think it's not defined here at all. Oh, of course not. It is part of characteristic range. Yeah. So set needs stuff here, and it simply adds to the signals do preprocess or do compile, but only if is at shader stage returns true, and that is defined in the characteristic range bridge, which is false, and it gets overridden only if we also derive from at shader stage, which is true here. But we do not. You know, at shader stage is not in the picture here. So yeah, this value really should stay 0 in this case for the base pipeline characteristic. And what it does then is something super simple. Multiplex is the kernel of the task, the implementation of the actual task. This is just framework, and it has only a single state. So it runs this begin to end, and then that's it. That's something very simple. It calls a few initialization functions on the flat create info. That means that is the create info is a vulkan thing Normally you have a vulkan struct, blah blah blah, create info. And you fill that struct and then you call a vulkan API function. And in this case, I want to create a pipeline, so we need a graphics pipeline create info. But that struct contains a lot of pointers that point to other structs. And yeah, I didn't want to create a lot of objects, so I put everything in one struct. And then that's why I call it flat. So this just contains all the information that is required or needed to create one pipeline, including the information that I give it here. Something about blends something and dynamic states, and I don't care. Okay, so super simple. And then it finishes. I mean, after running this, it ends with run state. That's just the argument of the function. Set to characteristic initialized. Break, so we break out of the switch. And then we run the multiplex implementation of the, well, direct base type. So that's the base class. Oh, this thing was set. That type is just set here. Using direct base type is vulkan pipeline characteristic, which is the base class. So we run the multiplex implementation of now how to find that? There's too many of them. It's probably easier to find it by just jumping to the base class itself and then finding it back. There it is. So this function is being called, and now I forgot what the run state was set to. Damn it, really. Go back again. Run state initialized. Yeah, of course. The D here is added, and that means we're done with initializing. So now back to that base class again. So then it runs this state, I call them, state of the task. I used to call it a state machine, but then I found out that it's a pattern that is already, the whole task thing is a pattern already, more or less, and that other people called it tasks. So I renamed it from state machine to a task. But I'm still calling this a state. Just go with it. So we run this state, and then it tells the factory, the pipeline factory, that this characteristic is now initialized. And then it checks if it needs a do preprocess signal. Well, in the case of our base pipeline characteristic, we don't. This is 0. So we skip this. This is also 0, so it does not do anything. And then we finish. And then if calling finish here, I mean, I don't have to show it. It just sets a bit, and then we return from this function. So we do not call this, we just really return. And that means that we return from no, I don't know. Hop, undo, no. Control T. Nobody knows where we are. My keyboard. There's something wrong with my keyboard. Sometimes I just starts to do weird things. So we return from this function now, and then therefore we return from this function, and therefore we return to the stateful task. Stateful task is called library, and since we have called finished, this task is never going to be run again. The task just finishes. You can see a task a bit as a thread, like so. We just killed the thread. The thread ends. The task ends. Not running anymore. Okay, the other characteristic is slightly more complex. That is defined here. That is derived not from characteristic, but from characteristic range, and also from add vertex shader, and also, because this is true, from add fragment shader, and also from add push constant. So we have all the base classes that I currently have are a base class of this thing, and that is going to cause M needs signals to be set to all the signals. It wants all the signals. It wants fill because of this. It wants preprocess and compile because of these two. And this one doesn't require any signals as far as. So that task then, we go to the multiplex here. That task begins here. Does some initialization again, and then it says we want to continue with fill. That is this one. But before we do that, we have to tell factory that we are done with initialization. So it sets the run state to characteristic range initialized at the D here. And we now do a break, which causes the break from the switch. And then we call the direct base type multiplex implementation. And then in this case, the direct base is set to characteristic range. So it's going to run, switch here, we're not going to run characteristic multiplex implementation, but we are going to run this one. Characteristic range multiplex implementation with the range. And well, the initialized. Now also calls characteristic range initialized on the factory, and then it sets a state to characteristic range continue or terminate, and then wait for the do fill signal. Which we only get when all the characteristics are done initializing. This is kind of a synchronization. If you have multiple characteristics, tasks, they all have to reach the point where they have been initialized, and then they all will be started to run the next stage, which in this case then would be filling it. So this one waits until also the base is done initializing. And then we run filled, which then, well, actually it's waiting for this, but when the signal is received, it's going to run that. So the state was set to that, which is defined here. But that just checks if we have to terminate, and if so, it just finishes. and otherwise it sets a state to the continue state, which is then the user state that will fill. So then we do break here, and then we run the fill state of the user, and when it is filled, it will come back here. And then say we are filled, and do the same thing as here, set the continue or terminate, and then, yeah, well, I wrote this code yesterday, and it's very confusing, and apparently not working. So let's just have a look now what it does. You see it just doesn't work. Pipeline is not available. The reason that pipeline is not available, I limited frames per second, by the way, deliberately to 10. Otherwise we flew it too much. So it prints this 10 times per second. And in the render loop it says, yeah, well, I would like to render, but the pipeline is not there. And the reason the pipeline is not there is because the pipeline factory never finished, never created it. And the reason that happens is because, and that's the question, what is the pipeline doing? I think the best thing to do is to write this to a file. There's troop, Dutch for junk. And then we edit it. I like to see the colors, and VI is not working with that. Now I can use less, but then it becomes a lot harder to jump around. Let's try it again, what the problem was here. That's strange. Seems to be have ended prematurely. You do have one warning that the pipeline is not available. It might not be enough. Yeah, I don't understand this exactly. Did we assert or core dump or something? Maybe I stopped it. No. Oh yeah, I did core dump. Oh, I did core dump. That, I mean, that's different from just when I just run it. It would just never ended. It just kept printing this. Well, I would have to do that in the debugger, but let's just try it again. Okay, now it doesn't core dump. Oops. Oh no, the scammers are back. Okay, it's VI troop. Yeah, now we have a long list of this. And the question is, what is the pipeline factory doing? So I'm just going to search for pipeline factory. And then you see that the pipeline factory appears in the debug output. The last line where the pipeline factory string appears is when characteristic range filled was called. Well, I think it's not normal that then afterward nothing happens, because we only have one characteristic now that waits for the do fill signal, and therefore we expect only one call to characteristic filled. And then the pipeline factory should start doing stuff again. I think that when this is just this pointer of the current object, so that's this pointer of the pipeline factory. And well, nothing. It never reacted to it. Okay, you can see what happens here. Also pipeline factory. I'll highlight that as well. Pipeline factory has its own field and initialized state, so do not be confused by that. But they start with pipeline factory. So it is not the ones we looked at, those were characteristics. But the pipeline factory itself waits until all characteristics are filled. And it does that by, so this is thread pool 3. And then 2 other threads run, and then thread pool 3 here again. It does that by waiting for characteristics filled. Hey. So rather it waits for this signal and then it will run that. And this signal apparently we never received. Characteristic filled is not received. And I think that signal, because it just, it stopped running. No need to run removing from thread pool. And that was it. And then we call the only characteristic that would do this, calls, hey, I have been filled, and then nothing. So something is wrong here. Now, I can already guess what that is, of course. So this function, it should do this signal, and it doesn't. And the reason that it doesn't is because m number of running characteristic tasks wasn't 1. If that was 1, and we subtract 1 from it, and then it is an atomic, so we fetch sub gets the current value and then subtracts atomically 1 from it, and then returns what the previous value was. So it becomes 0 if the previous value was 1. And when it became 0, then we're done, and then we do the signal. That didn't happen, so the value wasn't 1. Now, as far as I know, it should have been set to just 1. Maybe we left it at 0, maybe we set it to minus 42, but it definitely wasn't 1. And previously it was set to 2, because, well, 2 characteristics. But now it should be set to 1, because we have only 1 characteristic that needs the fill signal. I would definitely like to know what the value is. So I think I should just print it. Now, of course, there's a race condition since it is an atomic. So what I really should do is just decrement it and then print the resulting value. I don't think there will be any race condition, but no, okay, let's do it technically correct. So that is a size type. Definitely not going to be negative then. So we do size type previous value is, and now we just subtract 1 from it, and then I check the previous value. If the previous value is 1, then we are done. And now I'm going to add debug output to it. Well, if the signal is being called, then I see that, and then I know it. So it's just if that doesn't happen, or even if it happens, maybe afterwards, I don't know. Don't care. TS debug channel always, and then I say number of characteristic tasks is now. And that is then the previous value, and we just subtracted 1. So that's the current value. Okay, do the same thing. Search for pipeline factory, and here is a field is being called, and we have then always use this as a as a channel name, and it says that value is now that, and I bet this is minus 1. Right. I'm afraid I do not know this number from my head, but maybe I can try to remember it. It starts with 1844 and ends with a lot of 5s, with a 161 in GDB. Print hexadecimal, that number. Yeah, that's minus 1, all ones. So the value was 0 when we entered it. Well, that's definitely wrong. And very surprising, I think. Or isn't it? I don't know. Okay, filled. It is filled. It can only be filled when it started running the fill thing, what it would do after being initialized. So here we have set state characteristics initialized, wait characteristic initialized. If that worked, then it would wait until the previous characteristics, that's both called initialize, so they probably should check, but anyway, then we continue here. That's doing multi-loop magic, so we will ignore that. Magic, more magic. Never mind the magic. Till we get to the inner loop here, inner loop body. And then we do the thing. I set it to 0, alright, but then I run over all the characteristics. And I increment it if the do fill thing is set. Apparently none of them have that. I mean, otherwise it would have been incremented, it would not have been 0. But if none of them have this set, then the second loop would also never have this true, and therefore would not do anything, and therefore would not send the do fill signal. And this is all confusing. I think we really have to track everything in the debug output. Exactly what they do. Right now, however, I think I'll take a shortcut. And I know that in this case, it should have been 1. Equals 1. Otherwise, you know, something went wrong right here. That at least. Someone want to see my wallpaper? And you can see that. It's a good question. How do I do that? Workspace, config, restart, exit. I don't think so. Backgrounds. Now there must be a way to hide temporarily everything. No. I have too many windows open. Below this window there's something else and so on. Okay, do it like this. No, wait. Like this. So that's also not. And now I clicked on something. Well, anyway. That core dump. Well, it's a real core dump, isn't it? Not an assert. Well, the assert did not fire. Yeah, I have it here. Yeah. Now you can see it. And then I have 3 monitors, so that's. Oh no, in this case not. I used to have one that is just different on all monitors. But this is just a single image. Can also change them to backgrounds. A butterfly. This is a Cumberland's Falls. Mountain. Reflected wallpaper. It's a fish. Okay, let's change it. I need better what is it, wallpapers, I guess. Maybe this one for a while. I don't see it anyway. Well, now I see it. So yeah, sorry for you. Very boring wallpaper. Gotta be careful anyway. Sometimes I have visitors, you never know when your wallpaper suddenly pops up. So, nah. I keep them boring. Let's see, TT. Trip, stop it, and I'll have to look at everything, which is very boring to do, I think. Okay, so the first thing, we're gonna now start from the top. The first thing that runs is obviously the pipeline factory. And we start with the debug output that creating the pipeline factory. Then we see here the constructor, and then we see that it sets it's the first state that it wants to run, and we can highlight this pointer, so now we know immediately what refers to the pipeline. I mean, it is pipeline factory. Okay, it starts running it, starts running start, but I think we are not really interested until it starts running initialize. So we had sets initialize, but then wait for the pipeline cache to be set up, which takes a while. Set up, running, wait, here we are, initialize. Let's follow the source code at the same time. So let's use this, no, let's use pipeline. Just set that file. Which this is source code, and this is where we are. And we are running this. We are here now. That creates the move new pipelines task, runs it, and then says that the pipeline factory, itself is initialized. So we want to go here. Okay, that would be there. Now here. Now we are initialized. Then well, this should be 2, really. So this loop should have a size 2. And then we call set flat create info, which also has no debug output, but then we call run, and that should be visible, and that should happen twice. Hey, I'm always back. Run. Okay, top. So we're running this now. I think this is the first one, like immediately. And then this is the second one, right? I think that the handler is where the task has to run in, and that is queue number 2 of the thread pool. And then this is the parent, and this is the condition that we want it to send to the parent when the child task finishes. So the parent is going to, that is the pipeline factory, is waiting for, or is getting the signal characteristic initialized. But it should be waiting for that to happen twice. Something seems already wrong about that, I must say. Yeah, it's kind of weird. It's not how it works. See, it waits for characteristic initialized, but either of these, the first one that finishes will send that signal. If I run it like this. So then it would not wait for all of them, it would just immediately continue. That won't work. No, not good. What we really want is that this happens. This signal must be called here, come from here. As a result of both of them having called this function. The first one then subtracts 1, and then it becomes 1, and then the second one, and it becomes 0, and then we call it. Not on a first served, first finished. So I'll start with fixing that, I guess, without even looking further. Okay. Characteristics run. Yeah, I don't want it to send any signal, I guess. It should do a callback. In fact, it doesn't even do a callback. Oh, wait a minute. Yeah, normally this is not a problem. It was ignored. But now since my change, that base characteristic thing is finishing. So it does send that signal. So yeah, I'm not interested in sending any signal. Certainly not initialized. Now I should know from my head, of course, how many run things I have. I suppose I should be able to just do this. Pass it the handler and then not passing anything else, and I suppose it won't send anything back. Let's check if that exists. A run with just a handler. AI endpoint, something else. Application run. Synchronous task run. AI stateful run. That's the one. But it's the only one. Default handler callback function. Parent condition. This one, yeah. So we're just calling this one with the default handler, which is then the same thing as passing a null pointer 0 and do nothing, apparently. Okay, guess that's okay. Yeah, well, I don't know. Let's just compile it and run it again, because I guess it still won't work, but you never know. Let's run it here again. Quadrant. Well, it definitely changed. I think that the quadrant that we saw before is when there is a race condition between the two characteristics. So if, say, the big one finishes before the base, then it would do the same thing as that it is doing now. And then it would apparently core dump. So I think I fixed this part, but now it core dumps. So I'm gonna do run in GDB. People are maybe curious what that is. That is this. TT. And I'll run, and then it should core dump, right? Because that was very reproducing. Okay, I mean, don't get mad at me. I'm not being paid for this. No advertising on YouTube, right? So I just want to use the opportunity of having 30 concurrent viewers to, well, make advertisement for my Christmas stream. I'll type it in the chat. Christmas stream at 1800 UTC 25, well, Sunday 25 December. I will be attempting to prove the Collatz conjecture. You have to bring the hot chocolate yourself. 7 people left while I was typing that. Okay, they are not interested in chocolate milk. Now, the Collatz conjecture is something that no mathematicians have been able to prove in the last 100 years. And the remarks that they make is that mathematics is not ready for a problem like that. But the problem itself is extraordinarily simple. You can look it up. Collatz conjecture. Be prepared. Watch all the YouTubes you can find. I'm going to do a serious attempt to prove it. And of course I will fail, but we will have fun, right? And if I don't fail, then I will be very, very, very famous. The fun part is that it involves addition and multiplication and division, and that's it. Very simple. Very simple. It's a middle school mathematics. Except the proof. The proof is probably very difficult. Okay, let's continue with this. Okay, yeah, marshmallows. I'm also going to buy that for myself. Yep, we have the crash here, I think, but it's not really a crash. This is a validation error. Well, that's okay with me if that happens before the crash. Maybe we crash because of the validation error. Stage count is 0. Well, yeah, we do reach the create graphics pipeline. Finally. So, congratulations, as it were. Did you also compile stuff? Yeah, compiling. This looks like the vertex shader. And we should have a fragment shader as well. We probably don't. Maybe that's a problem. Stage count must be greater than 0. Yeah, that stage is well, the vertex shader or the fragment shader doesn't even know anything about the vertex shader that we did compile. So definitely something missing here. Can we find back stage count in my own debug output? Yep, there it is. Stage count is 0. No, I guess it's all trivial. I mean, I changed so much code that's just, you know, I left half of it away, as it were. But yeah, no. Let's have a look at where this is being called, and then the second argument is an object that contains flags followed by stage count, and and no stages at all. So this is also empty. We do not have any stages. Oh, okay, yeah, we don't have anything at all. Anything at all. This is empty, this is empty. Basically, we're trying to create a pipeline without initializing anything. Looks like it. Yeah, and I think I know why. Okay. But it's not 100% clear to me what needs to be changed, so I'm still going to look at that point and then backtrack through the code. Where is it being called except here? Oh, that's a different test. Declaration, debug output, implementation, I guess, definition. I'm GUI, we're not doing that yet, so this must be the line. Yeah, there it is called. Yeah, this is where it is being called. So have a look there, and it's calling it with second argument pipeline create info not being initialized correctly. So we search upwards in the code for that struct, and here we have the struct, and we knew that p stages is empty, so this is empty and the rest is also empty, but who cares? Let's look at one thing at a time. So I'm going to look upwards in the source code for that thing which is empty, and there it is. It is just a copy of whatever the flat create info returns. So the flat create info wasn't initialized. That's basically the deal. Now, what does it return? The flat create info returns here get pipeline shader stage create infos, and that is a merge of this vector of vectors, I think. Now merge is just a catenation at the moment of all the vectors in this vector. So let's look at the list. List type defined here. It is a mutex protected vector of vectors. And I bet that even this vector was empty. Nothing was added at all. So then the merge is going to say, well, let's merge 0 vectors, and then you get an empty vector. So now the question is, why is it empty? So, oops, if I look for that thing, then where would it be filled? Right there. This is the merge, and here it is, oops, there's defined, here is it filled. What this does is get a right axis type, it means it locks a mutex, and then we have a variable that we can use to access that thing. And then we do a pushback. So this function, oops, this function is never called. And the reason that the function is never called is drums. I never call it. Lens. I'll show you why I never call it. Switch. Oops, we're already there. So you have to remember this. There's pipeline shader state create info vector. Can I remember that? No, I'll just copy it. But then I cannot no. That's not there. Okay. I can still show you why I'm not adding anything. Here's the add. They are all commented out. And there is a fix me. So we basically run into this fix me. Do this in the add base classes. That's what it says. Now I'm still interested in which of these things would be that. Pipeline shader stage create info. That one. Yeah, it's commented out, that's correct. Even worse, it doesn't exist anymore. It does exist. Well, that's a lot better. It exists. And well, in add shader stage. With a bit of luck, it's even filled. Nope, it's not filled. Seriously? Seriously? We do have this one. Wasn't it the vector of pipeline shader stage create info? Maybe it's still in my mouse bubble. No. I think it was. Pipeline shader stage create info. Yeah, definitely. That's the one. Pipeline shader stage create info. So why does add shader stage only have one of these? Now, if it's only one stage, then it would only have one of these create infos for it. But this is a virtual base class, and it is the virtual base class of both the add vertex shader and add fragment shader. So it is possible that both the vertex shader and the fragment shader share this base class, in which case we need two of them. In which case, I wonder y, etc. But on the other hand, that's a fun thing of my tasks. They are virtually single-threaded. They only one thread at a time runs them. So if this thing represents multiple stages, because it is a virtual base class, and you have multiple stages, like I have an add vertex shader, which is derived from this, and I have an add fragment shader, which is derived from this, and maybe in the future I'm going to have an add foobar shader, this is derived from this. Then all of those things are going to happen one after another. And single-threaded, so there's no locking needed. And what I could do is assume that it is going to fill this one, and then add that to this vector in the end. And then maybe I'll do it again for the other one, and then I add it also. And I'm getting a growing vector with create info for each of the stages that the total characteristic object represents. But before I implement that, let's have a close look at how it fills this and from where, etc. Thank God it is being filled. It is being filled by a call to build shader. And this is add shader stage. So yeah, nobody knows why I even have this thing. Might as well put it directly into the shader stage create infos with an S at the end. AKA push it back. Because I don't think this is used anywhere else, right? Grab project sources. Yeah, it exists and it is filled and that's it. And then it disappears into nothingness. Nightcast, well, by watching my streams, of course. No, by coding yourself. Start coding. Yeah, I think we can do away with this thing here. No need for it. Why would I sign it and then not use it? There is one minor problem, however. That is also possible that we have two different tasks, or multiple tasks, that concurrently create multiple stages, and they also have to end up in that vector. But hey, those would be those would be the vector of vectors. I think so. Yeah, I need to end up with a vector of vectors, right? And I'm not even having that yet. This is just the thing. This is a vector of those things, and we are going to have. We need a vector of vectors, vector of these vectors somewhere. So let's start with deleting this, and then put them directly into this by simply pushing it back. At least I'm using it. So that becomes that thing, and then place back, same as push back, but then you just pass all the arguments. And actually we don't have arguments because then that would be the arguments of the constructor, and we don't have that. If it did have a constructor, then you could not use a designated initialization, as we are doing here. Yeah, might as well use pushback. I think the compiler is smart enough to ignore that thing. Let's see. Now I need to know the type still. And you could try it like this. But it's not going to work. Because it cannot do the designated initialization when it doesn't know what the type is. Annoying. But that's a type. I'll just tell it what the type is. That should work. Now this creates a temporary here. There's no way around that. And then the temporary is being pushed back into a vector. Now, yeah, well, you know, very annoying. What you want to have is, of course, that it is the emplace back would be nicer, I think, because yeah, no, I don't think we can work around this. What you would like is that it allocates memory and then writes to that memory directly. And now it's probably going to write to the stack and then copy the stack into the allocated memory. But hey, it's not CPU critical. It's just compiling a shader. Compiling itself takes a million times longer than this copy. So we're going to do it like this. And then this vector must be added to the create info. That's that add call. And it must do that in a thread safe way. Dima, this Vulkan engine 2 years ago, about, give or take. Let us think. So somewhere I need to have access to the flat create info, which is a member of the pipeline factory. And then we have to say add and then this vector. We can do that super early. Just registering a pointer to this vector, saying we are going to fill this vector, and then, you know, once we're done, we'll tell you, and then you can do your merge thing. But multiple tasks, multiple characteristics, might want to do that. Might want to do that concurrently, which would require a mutex and stuff. However, I'm not sure if that is the case. If, say, we do it in a smart way, in a smart point rather, yeah, maybe I'm making a mess of it, but I think that we could do it in a create function, because that's at least then it's, you know, like one after another. Yeah, directly after creating the whole thing. I have to remember that we need to add this on. I'll just keep the editor open, I guess. So I forgot what the name was of that function. We sorted this stream. Add, it's not just add characteristic. Yes. No. It'll look like it. There it is, hidden at the bottom. So here it is created, and then directly after creation, then all the virtual tables are filled. I'm already calling a set need signals from here, and I might as well now add more stuff like do your thing. Well, thing is register with the flat create info. Register with the flat create info. I heard someone say that, so I just typed it over my auditory memory. And then, yeah. But that means that this must exist, this function, for every characteristic. Absolutely every characteristic. And there's only one base class that I have that I can add it to then. And that is the characteristic range, which is the base class of the characteristic period. So even my base pipeline characteristic has that as a base class. So that would be characteristic range.h there. And I guess that the set needs is also here added here, right? Set needs signals, yeah, and then directly below that we're going to do that one. But now we are here, and actually we want to be in at the add shader stage, if it even exists. So maybe we should not add it here. Unfortunately, this one also has base classes, among which the characteristic range bridge. Yeah, how many vectors does this thing have? Nothing. I mean, that's just arguments. No real vectors. Also no vectors with a capital V. Characteristic index. Nope. Might as well go to that bridge then, I guess. Well, let's not add it here, but add it to the virtual base class of this base class, which then also is, you know, base class of absolutely every characteristic. Shader stage is going to implement this one, so we might as well add it here then. Virtual. It's not const. It's not const, right? No, it's not. Is it not const? Actually, it is const. We need access to the flat create info, but oh. Okay, I changed my mind. Let's pass the flat create info to it. Well, otherwise I have to, from this virtual function, I have to call that virtual function. And we just got from this, from the class that implements this. So, pretty sure this console. And then the default's not doing anything. But I do want it to pass the flat create info, which is probably type flat create info. It lives in namespace pipeline, and we are now in pipeline, so that's nice, that's good. And the flat create info must be well, reference or a pointer. I guess reference. I'll call it flat create info because I'm creative. No, seriously, out. It's like the output variable. And then here we're going to delete this part after copying it, because hey, this reads better. Register with flat create info. Right. But then from the characteristic range, we had this set need stuff here. I'm still going to add that function. Then, as it were, and also const. And that is then calling the virtual function register with. And then we have to pass a non-const. That's not going to work. Where's my flat create info anyway? Oh wait, actually, no problem. Flat create info is part of the pipeline factory. So I'm going to pass the flat create info. And then this function must return a non-const reference. To a member of itself, which is only technically going to be a nice, you know, not horrible code if M owning factory is a non-const. And it is non-const. We have luck. See, non-const. So everything is working out here. Yeah. Well, maybe you know, the register width is a bit short, but on the other hand, we pass a flat create info reference, so I think it's clear enough. Yeah. So directly after creating a characteristic, which derives from this class, we call this function on it, which then calls register with reference to the flat create info, which I still have to make work. And that register with is then defined in characteristic range bridge, which is not doing anything, but the add shader stage. Oh, that was already open somewhere here. The add shader stage is also derived from the characteristic range bridge, so it can implement that. Oops. Yes. Void register with flat create info. Reference flat create info out. And that was cons, wasn't it? And this is an override, pretty much final. No. Let's add the same comment as here. Override of characteristic range bridge. So then we get here, and that then calls flat create info out dot add. And then our vector, this one. Yippee, now it is added. Well, except for one minor detail. So this thing is now being done by the base class. I'll just delete it. And the minor info was a minor complication, or what is it? The thing that I'm still missing is that I'll just make it. We'll see. The accessor to the flat create info. Yeah, sorry, it was compiling. Audio didn't work. What is this? Flat create info in not declared. Well, it should be declared because I'm calling something on it. Can I add the flat create info to this header? Oh, abort. Abort. Quit. Editing into editors at the same time. Yeah, okay, so flat create info. How big of a header is that? That includes set layout, set index hint map. No. Maybe I can include it. You can try. Let's try it. Flat create info. Hello everyone. Sunday in Clarita. What is this? And Shaka. Oh no, there was no Shaka. I don't know what the name was. This was not Shaka. Error, flat create info has not been declared. Oh, that's here. Well, in this case we can just forward declare it. It's not just simply something in pipeline. Clarita, yeah. It is more or less described in the description. And the title of the video. No matching function for call to add. Okay, so what I thought was missing is a flat create info accessor. And indeed, it should be missing. I want to add that one first. Pipeline factory. It's a Vulkan engine, as is described in the description and the title. What did it just do? Flat create, flat create. There it is. I want an accessor to this thing. We don't have it. Accessors. We have accessors. We have accessors. No. Well, this is really dirty. This is just feels wrong on every possible way to give access, to give non-const access to a member. To copy that. That's not object-oriented coding. I mean, I might as well make it public. Right? This thing is private. But by allowing a non-const reference, I can do whatever I want with it. Anyway, so I might as well make this public, which means that it's not object-oriented anymore. So I would at least call this dirty coding. And yeah, I'm not happy with it. And what would be the correct way to solve it? Now, normally the way to solve it would be to rename this function and let it do whatever the caller is doing. So maybe I should do that. But that means, we might have to do this a lot, calling add on the flat create info. And then we'd have to more or less duplicate the interface of the flat create info object. Now imagine that the flat create info object didn't exist, and we just put all of the members here that it has simply as a member in the pipeline factory itself, and then also all the member functions would become member functions of pipeline factory, which means then that we could call them directly on the pipeline factory, the add and stuff. Well, that of course would more or less pollute the pipeline factory, and that also does not really feel like object orientation. It's nice to have a flat create info and then with its own interface and its own state, internal state and stuff. So I don't want to do that, but I also do not want to repeat all these functions that it has in the pipeline factory. But all these add functions, they are non-const. So that would mean that I need to give access to non-const access to my flat create info member. Now what I could do is use a template. That would make it significantly shorter. A template that simply does all the adds. I think the add is going to be the only one that we really want, even though I'm calling it register at the moment. It's kind of the same thing. So here we have int add and then a standard vector of some type. So actually a pointer to a constant vector of some type. This add also a constant pointer to a vector of some type. And then we have another add here, which is also a constant pointer to a vector of some type. And here is another add, constant pointer to a vector of some type. And here is another add, constant pointer to a vector of some type. So I do see a pattern here. Again, constant pointer to a vector of some type. So maybe you only need the add. At least now we need to add. So I think I'm going to add a template to the pipeline factory, which then in an inline way, so it's not making anything slower, provides the direct access to the flat create info, but then only to the add ones, to the add functions, and not the whole thing. Which then would look like this. Instead of giving full access, I'm going to do template type name T, and then we don't return anything. We do add to flat create info. So void. And that is a standard vector of some type, and it is a pointer to some vector. Yeah, let's call it a list. And then pass that list on, like that. Now we have all the adds at once. And they are at least forced to be a standard vector, constant pointer to a constant standard vector of some type. Now, using concepts, I could even restrict this type to the possible types, but it's restricted anyway, because if you pass a type that the flat create info doesn't know about, it's going to the compiler is going to complain here that it cannot find the right add. So I'm fine with that. This feels at least safer. And yeah, let's do it like that then. Okay, so now I still do not have an accessor. Where do we call the accessor from? I called it from, well, I thought at shadow stage. .h. Wait, this register with, no, it's the one that calls this. Register with TPS, register with, which is being called from that top line here, characteristic range.h. Okay, now I'm confused. Yeah, so we do not have a characteristic width. Sorry, register width, but yeah, that's also not going to work. Register width was is a fertile function of my bridge to get to the right class. It's not good. Let me wait. Okay, so what I just added, the template add, doesn't really help to fix this problem. I mean, then I would have to, we cannot pass this flat create info reference. I would have to pass the pipeline factory, and then we can call the add on the pipeline factory. Well, that will work now. I'm not sure what that is. Is that better? I think it's better. It's probably better. Let's just do that. Going to pass the pipeline factory as a pointer, I think. No, something like that. Yeah, so now we're not going to, I mean the downside, now I have to include the pipeline factory here, which probably won't work because that's a really huge thing. Pipeline factory, let's try it. That's kind of silly almost. Okay, I think it's a task, right? Pipeline factory. It seems to work though. You can just include a huge header inside some other header and no problem. Yeah. Register width is marked final, but doesn't match whatever we had. I wouldn't know why. Which. Because it is a task. Right, I keep. Oh, you already have a pipeline factory task for declare there. Thank you, Hausamati. Mystery asks why use const pointers and not const references. That is a good question. It was a problem here. I don't have a good answer word. Says the neural pathways in my brain tells me when to use what. And in this case, I just want to use a pointer. What is the exact reason for it? It's a good question. I think it has to do with where the thing lives, to the lifetime of it. I still didn't read the bloody error. And it is so dark that I cannot see my keyboard anymore. Cannot convert const standard vector to AI state. What? And here it was. By the way, it's not const. This is not const. If it was const, then I would probably want to use a const reference. But it is not const. I hate non-const references. They are scary. Why does it think that my ad takes... Yeah, I guess I have an add. I have an add in AI stateful task, I guess. No. Pipeline factory. It is in pipeline factory itself. Didn't I just add an add in pipeline factory? No, I added an add to flat create info. Comment it. Add shader stage.h. No matching function for call to add to flat create info. Calls reference. No, that must be a pointer. Candidate const pointer. Oh, you mean this one? Yeah, that must be a pointer. It's I cannot store references in a vector like that. It's all about pointers. So I have a vector of pointers, two vectors, but it's still a vector of pointers. You call them references, but nah. I want to know that explicitly, even though I have to add the ampersand, this line tells me that my vector, my member, is going to be stored somewhere as a pointer. So something has a pointer that points to one of my members. So it's a lifetime thing. If I see this, I know, oh, someone is using a pointer to my member. That means that the lifetime of this object must be longer than the lifetime of whatever I'm adding it to. And if you remove the ampersand here, it tells you nothing. It could be that it's just temporarily using it. I mean, that's how I'm reading it then. Because it just said add to flat create info, blah, blah, blah. And then when it returns, I guess it's done and I can destruct myself. But you cannot destruct yourself. You cannot do a delete this immediately after, say, because, yeah, something is going to have a dangling pointer on that. So I really want to know that happened. That's why I'm using pointers. CQ, I couldn't tell you because one, I never coded in OpenGL, so I have no comparison really. And I never coded any graphics anyway, so I don't know if Vulkan is worth it because this is what I have. I cannot compare it. But okay, I have some knowledge, of course. I talk to a lot of people who are professional Vulkan coders. And I have a lot of, I mean, when I needed to learn so from someone. And my personal opinion is it's not worth it. If you have a goal, if you want to write a game, if you want to, if you have a deadline, you want to just write, I don't know, some game, and you want to have that game out there at some point, then I don't think it's worth it. Yeah, it's gonna take you 2 years more, say, at least. So, but that's only a hearsay, because I never coded in OpenGL myself, so I don't know how much easier it is. But yeah. And Dixon here is the hero of the day. I'm not using printf, Dixon. That's C. I only use O streams. But you're welcome anyway. Hey, it compiled, yes. Let's run it. Crash, of course. But where did we crash? Did we pass the last crash? Or did we not? Or rather, did we get rid of the... I just have to run it in the debugger again, I guess. Nope, that was not the terminal. So annoying, isn't it? This one then, maybe. Yeah, that's the one. Run it. Run it. What do you think? What is the validation error that we have today? No validation. Oh, we have a validation error. We do not have a validation error. No, we no longer have a validation error. Or we just have a new bug that happens before the validation error. That's also very possible. Looks like it even. This is 230. No, don't think that's going to work. So we're calling that on wrapper. And what? So basically, this thing here is nothing. Cannot access undefined list. Okay, one big misery. I think it's time for me to stretch my legs and then continue later. Because I feel like it. It's still a little bit light outside. Or yeah, I should, you know, but why is it so early dark? Yeah. Yeah, I need to go.